Hello, my name is Zach Chenoweth, and this is my presentation of Lab 4, Task 3, Path Planning with Noise. So in this task, we have to have our robot start in a starting location and end in a goal location. And then we have to use some path planning algorithms to plan the shortest path to get from start to end. So just like my previous video, I'm going to use the wavefront algorithm. And basically all this algorithm does is it places a 2 in the goal location, and then it basically counts the spaces, the possible spaces to get to the starting position, and then the robot's going to take whatever path has the least amount of spaces. So for the code, here we have the goal cell position, the start cell position, and then the direction it's facing. Here we have the grid data structure that's basically holding the map, so it shows all the internal walls and external walls, so the robot knows when there's walls and not. This print function is just going to print the maze when we ask it to. The wavefront algorithm is the same as from my previous videos, so basically this is what's going to place the 2 in the goal pose, and then it's going to go through each cell that it can move to and place the next number, and so on, which I'll show you here in a second. This planned path function basically is after all the numbers have been placed, it's going to go through and plan the shortest path and all the motions it'll take to follow that path to get to the goal pose. It uses a lot of if statements and so on. You can see that in some of these cases I have multiple movements, and that's because in my turning functions here down here, all they do is turn 90 degrees. They don't move forward, so I have to account for however many motions in this, and that's why there's so many. And then once our planned path has been created, we're going to go ahead and return it, and then we're going to move on. Here's the forward function. This basically just makes the robot move forward using the position sensors. Turn left is going to use kinematics to calculate the velocity it would take to turn 90 degrees in 1 second. And then it's going to set the wheel's velocity to those so it turns left. Turning right is the same thing as turn left, except instead of turning left, we're turning right. So it calculates the velocity, so on and so forth. And then travel path is basically going to perform all the motions for our planned path. It's going to go through the planned path and it's going to perform all those motions. So now that we've seen it, let's go ahead and see it run. So here we have our starting position is cell 16 facing east, and our goal pose is cell 6. So here we can see it initially puts a 2 in cell 6, and it's going to move and put 3s in each of the next locations that it can possibly go. So because it can go down or to the left, it's going to place a 3 here and here. Then it's going to place 4s here and here, 5s here and down here, and then 6, 7, and 8 respectively until it reaches this goal pose. Once it reaches that goal pose, then or when it reaches the starting pose, then it's going to go ahead and start the path. So you can see the planned path down here. So in order to reach that path, the shortest path would be to go into cell 15, 14, 13, all the way into 8. So let's go ahead and see the robot travel that path. So you can see it moving. Now these, here in the square brackets, you see these letters. These are the actual motions it's going to perform. So for the first motion, it's going to do 2 left turns, then a forward motion to get into cell 15, then a forward motion to get into cell 14, forward motion to 13, a right and forward to get into 9, and so on until it gets there. So this is the motions it's going to complete. This is the cell that it's going to. And then once it reaches its goal, it's going to go ahead and print goal. Let's go ahead and see it again. So let's put it, the robot in cell. Put it in cell 10 here. And then let's say we want cell 16 as our goal pose. And we're facing north, so let's go ahead and put north. Save that. Now let's go ahead and see it run. So let's go step by step so we can just see it work. So you can see here, it's going to go ahead and put a 2 in the goal cell. It's going to send 3s out, then 4, 5, 6, 7, 8, 9, and so on. And then once it gets to where it wants to be, once the number reaches the starting cell, then it's going to go ahead and print the planned path. So from where we're at, the shortest path to get to our starting cell would be to go forward, left, left forward, forward, left forward, forward, forward. So it's going to travel this corner here. So let's go ahead and see it move. As you can see, it's traversing the path just fine. And then it's going to get into the goal cell and print goal when it's done. So once again, my name is Zachary Chenoweth, and this is my presentation for Lab 4 Task 3, Path Planning with Noise. Thank you for watching and have a good day.